Today we're going to talk about solving quadratics by the graphing method. A quadratic equation is a non-linear equation that can be written in the standard form ax squared plus bx plus c equals 0, where a is not equal to 0. So that's kind of like a math definition. Obviously, if the a was 0, so if this was 0 right here, the 0 would negate this x squared, and you would actually have a linear function, right? Because you'd have something bx plus c or mx plus b. So a can be anything except 0. So in Chapter 7, we solved quadratic equations by factoring. So we can also solve these quadratic equations by the graphing method. So here's how you would do it. So step 1, we're going to write our equation in standard form. If our equation is not in this form where the 0 is by itself, obviously we would rework it and move things so that we get ax squared plus bx plus c equals 0. So step 2, we're going to graph the related function and take the 0 and just make it a y. So we're going to graph the function y equals ax squared plus bx plus c. So we'd use the negative b over 2a to find the axis of symmetry, use that x value now, which is part of your vertex, to help find the rest of the vertex or find the y value, and then make your table so that you can find what the graph looks like of that function. Then lastly, what you're going to do is we are then going to find the x-intercepts. And I'm going to write one more thing here. If any. So sometimes we're going to get x-intercepts, which will end up being our answers. Sometimes we will get one x-intercept as our answer, and there are going to be some cases where we don't get any. Now remember, the solutions, or the roots, are the x-intercepts of the graph. So in our first example, we're going to solve x squared plus 2x equals 3 by using the graphing method. So our very first step is we want to turn this into standard form. So to do that, remember, we would turn this into, we would move the 3 over to make everything go to one side. And that's now going to give me x squared plus 2x minus 3 equals 0. Now, in Chapter 7, we looked at maybe factoring this. But as you can maybe see from this, I can factor this, but let's use the graphing method so that we can see our answer as well. So here's what we're going to do. We're now going to graph. So that was step number 1. Now we're going to make the graph. So what I want to do is graph x squared plus 2x minus 3. So just looking at how we graphed in the last chapter, chapter 8, my axis of symmetry will be sitting at negative b over 2a, or in this case, negative 1. The vertex, when I plug in my negative 1, becomes negative 1 squared is 1, plus 2 times negative 1 is negative 2, which is now negative 1. And then when I subtract 3, I get negative 1, negative 4. So now I'm going to go ahead and start making my graph here. There's my y-axis. There's my x-axis. We will start plotting a few points here. negative 1, 1, 2, 3, 4. I know it's opening upwards, so I don't need to go below that. We also know that within standard form, the y-intercept is 0, is the c value. I'm just going to draw this axis of symmetry just so we all remind ourselves that that's where we knew that this vertex would be sitting because of the axis of symmetry and the negative b over 2a. Because of the axis of symmetry, I also know this point will be sitting here. And again, if I just would think about my table here, without having to make really a table here, I have these 3 points right here. I think it would make sense to go one more to see what happens. So I'm going to just kind of make a makeshift table and say, what if x is 1? So if I made x's are 1, notice that gives me 0. And if that's the case, then I know 1, 0 is one of my points. And by the idea of the symmetry, there is the other one, which would be on the other side there. Remember, we always try to draw a nice smooth curve the best we can. Ideally with a stylus is not as good as what you could do with a pen. And then we know the solution here are the two roots, or these two x-intercepts. So my answer, to give an actual answer for this, my answers will be x is negative 3 and x's are 1. Both of those answers would provide the roots. We could definitely check this. It's definitely not a bad idea to check this. If I was to plug in negative 3 back up top, negative 3 squared is 9, plus 2 times a negative 3 is negative 6. 9 plus a negative 6 is 3. If I was to plug in the 1, 1 squared is 1, plus 2 times 1 is 2. 1 plus 2 is 3. So it checks. Not a bad idea to make sure you have the right answer, but there are two solutions there. So now we want to solve this next example. We have x squared minus 8x equals negative 16. So my very first move in step 1 is to bring that 16 over by addition to make the standard form equal to 0. So there's step 1. Now we want to make the graph. So again, I'm going to go through my kind of key points. My axis of symmetry is negative 8 over 2 times 1, which becomes positive 4. Then, to find my vertex, we know that the 4 is the x value of the vertex. And if I plug that in, I would get 4 squared is 16, minus 8 times 4, which is negative 32, would give me the negative 16, plus 16 does give me 0. So when I plug in that, I get 4, 0. So now what I need to do is start looking at my graph. Yikes, that is not a good line. Let's get that one better. So because I know, just notice why I'm thinking this out loud. This is an opening upward parabola because the a value is positive. The vertex, we know, is the minimum or the maximum. If we're opening upwards, it's the minimum. So I know I'm not going to have any points below 4, 0. So I'm going to just leave a little bit of space, but I'm going to put this x-axis way down at the bottom because I know I'm not going to have anything in the negative for the y values. Something to kind of think about so you're not wasting lots of space on things, just to kind of help yourself create your graphs. So we know 4, 0. 1, 2, 3, 4, 0 is right there. Okay? Now in this one, I know my y-intercept, but that's at positive 16. So we got two choices here. What I could do is I could say, I'm going to change my scale to 2s. 2, 4, 6, 8, 10, 12. So I could do this, right, and say, I know my y-intercept is sitting right there. again, my axis of symmetry is going through right down here. Now, the way I drew this, though, I will have to admit, is not the best way because we would come off my graph a little bit. So I'm just going to kind of estimate a little. So if I was to go 1, 2, 3, 4, and then across the top, it's somewhere here, which would be at 8, 16. All right. So that would be another point based on my symmetrical look. And then I would probably just say, well, let's just pick one more point someplace in the middle of that just to make sure we can kind of see where this thing should be heading next. So if I was to pick, I don't know, 3, because we were at 4 for the x. So if I was to pick 3, when 3 goes in, I would get 3 squared minus 8 times 3 plus 16. That would give me 9 minus 24 is what? Becomes negative 15 plus 16 is 1. So when we plugged in the 3, 1 comes up. So that would be another point. So when 3 goes in, 1 comes up. And again, by our symmetrical, we would know that when 5 goes in, also 1 would come up. So I would get some sort of a curve looking like this. And then again, what I need to look for, we're looking not just for the graphs in this section, we're now looking for the solutions. So again, the solutions right now are the x-intercepts or the roots. So they're sitting right here. Those are the zeros. So that would mean in this situation, I only have one of them. So there isn't 2 answers to this quadratic. There's only the one answer. So we have another third example here. Negative x squared equals 2x plus 4. So again, our first step is to get everything to one side so we create the 0 on the other side. Now in this case, because of that negative x squared, I'm actually going to create the 0 on the left side and move the negative x squared over because that's not going to make it a positive x squared. I like positives better than the negatives. There's less chance for mistakes. I'm still going to then go through and say axis of symmetry. So negative b over 2 times a is negative 1. With the negative 1, I can now go and find my vertex. We know the axis of symmetry is the first part of my vertex. And when I run it through, negative 1 squared is 1. Plus 2 times negative 1 is negative 2. So 1 minus 2 is negative 1. Plus 4 is a positive 3. Now again, in this one, I know that this graph is going to be going up, right? Because we've moved it. Don't get tricked thinking in the beginning it's a negative x squared, so it goes down. Once it's in the standard form, it tells me it's going to be going upward. Okay? So because of that, when I make my x and y axes, I know I'm not going to go any lower than negative 1, 3. Because again, that would be a minimum in this situation. So when I go to plot those points, negative 1, 1, 2, 3 is sitting right there. My y-intercept is the plus 4, which is the c at the end after I put it in standard form, which means that there's another point on the other side. And maybe I go to what happens when x's are 1. So if x's are 1, I would get 1 squared plus 2 times 1 plus 4, or 7. So when 1 goes in, I would get 7, which means that would be the other point. Now notice, when I draw my parabola, what do we see? Well, one thing we don't see is we don't see anything down here as an x-intercept, so there's no solution. There are no zeros. There is no root to this. Because we are not ever hitting it, there is no solution. So we can get 2 solutions for a quadratic. we can get one solution for a quadratic, but we can also get no solution, okay? And if you see a graph like this picture where it doesn't cross the x-axis, there is no solution. And the last thing we've talked about we've talked about the zero of a function. Remember, a zero of a function is just simply another way of saying the x-intercepts. So the x-intercept is when the y is 0. So when the y's are 0, that's the value of the function. So we call that, when y is 0, the 0 of the function. So in example 4, finding the zeros of a function. Well, this is actually called a cubic function. But I see 3 times that we see the zeros. We see one right here, we see one right here, and we see one right here. So the zeros of function f would simply be -1, 2, and 3. Now, to be able to prove this, we would just plug them in. So remember, when we have a function, we can actually just plug these numbers in to see that they come out to a 0. So let's just do that just to kind of see them. So this f of x, so we'll use the function notation just to remind ourselves of how that works. Remember, if -1 goes in, the f of -1, I would then plug in 1 minus 3, and then -1 squared minus -1 minus 2 to the second set of parentheses. And then 1 minus 3 is -2. But notice on that second set of parentheses, -1 squared is 1, minus a -1 is 2, minus 2 is 0. Which basically means that second thing, the zero product property, comes into play, and that thing equals 0. So that checks the first one. If I look at the second one, if f of 2 is what I think is an answer, I would then say 2 minus 3 is 2 squared minus 2 minus 2. But again, 2 squared is 4, minus 2 is 2, minus 2 is 0, so the zero product property kicks in, and it doesn't matter what that first grouping was, that one checks. And then lastly, when f is 3, I would have 3 minus 3, and then I would have 3 squared minus 3 minus 2. And again, in the first grouping this time, 3 minus 3 is 0, so it doesn't matter what the second grouping is, the whole thing with the zero product property makes that one 0. So that verifies when those numbers go in, the zeros of the function will be coming out after the y values. So there would be my answers, or the zeros to this function. So hopefully a lot of this we've been talking about. There's really not a lot of new stuff in this section. It's just a reminder that solutions and roots and x-intercepts and zeros are really all kind of saying the same thing. We're using this graphing method to solve these quadratics, and later on in this chapter we're going to show you some other ways to get there. But hopefully it makes some sense, and if you have any kind of questions, please feel free to ask me when I see you in class.